For the next speech, I would invite here Claudia Doria, Communication and Project Manager at Li2C, with the speech, SYSCHEMIQ, Demonstrator of SYstemic Solutions for the Territorial Deployment of the Circular Economy in the Trilateral CHEMIcal Region. So Claudia, thank you for being here. The floor is yours.
Thank you. Thank you for your introduction, and to Tondo for inviting us today. As you said, I'm Claudia Doria, Communication and Project Manager at Lombardy Energy Cleantech Cluster, in short, LE2C. Today, I would like to share our experience and our involvement in the SYSCHEMIQ project. Okay. And I'm going to talk about circular economy, circular materials, focusing on a critical issue, the recycling of plastic packaging waste. So just a few words on who we are. Our journey started in 2009. When Li2C was established as one of the 9 technology clusters promoted by Lombardy region. We are the cluster of energy and environment. Today we have almost 140 members, including companies, research centers and universities, but also trade association and public administration. Our mission is to foster a structured dialogue and synergies between industry and research worlds, to promote open innovation on regional, national and European level, and to act as a driver of innovation and sustainability. We operate in 6 strategic areas. The circular economy area is cross-sectorial, and within this framework, we are involved in 5 European projects, 2 national and 1 regional. Among these initiatives, SYSCHEMIQ stands out. SYSCHEMIQ is a research demonstration project funded by Horizon Europe program with a budget of 9.6 million euros and a duration of 48 months. The project aims to facilitate the systemic transition to a circular plastics economy, with a special focus on waste from plastic packaging. So we are working to increase the reuse and the recycling of the plastic waste, and to improve also technologies for collection and sorting of the waste, and also to foster exchange of knowledge at the European level. The consortium includes 21 partners from 5 European countries, the Netherlands, Belgium, Germany, Switzerland and Italy, including industries, scientific institutes, education, public administration, cities and European network such as Li2C. Using a dual track approach that is a peculiar feature of the SYSCHEMIQ project, we combine the technical and institutional levels to involve the entire plastic value chain. So why it's really urgent to act? According to Eurostat in 2022, only 41% of plastic packaging used in Europe was recycled. And also European Commission estimate that there could be a 46% increase in plastic packaging waste by 2030. Also, the European targets require us to recycle the 40% of all plastic packaging waste by the end of 2025, and the 55% by 2030. So we are working in synergy to address technical, economic and social challenges related to the transition to a circular plastic economy, developing circular governance models and tools, building a circular solution for plastics, and promoting replication strategies and scenarios. So in this 2.5 year of the project, we identified some barriers. For example, virgin plastic is cheaper than recycled material. Also, the regulation across European countries are fragmented and main recycling plants are inadequate. And last but not least, also the citizen participation in recycling is still insufficient. So for that reason, we are working to provide guidelines to promote tax incentives and obligation for the use of recycled materials, but also to develop harmonized European standards and to create circular governance models. In parallel, we promote innovative technical solution for plastic design, collection, and recycling. For example, we are working to apply design rules to make packaging easier to recycle. For example, eliminating problematic materials such as multi-layers and also promoting mono-material solution. But also we are trying to use AI-based technologies to enhance waste stream quality, and we are promoting a more efficiency of mechanical recycling. In the same time, we are promoting also the chemical recycling, such as pyrolysis, to reduce the dependence on fossil-based materials. I will show a short video in which some of the SYSCHEMIQ partners will explain how they are working on pyrolysis. So.
Today, we are here at Ghent University to see this pyrolysis experimental unit that was built for the SYSCHEMIQ project. This unit converts plastic waste into pyrolysis oil that can be used as raw material for the production of circular plastics.
This means that you will heat up, in this case, the plastic waste. And this unit has all the elements of really an industrial plant. So the starting point is an extruder. An extruder, you really push the plastics and you make it into a liquid. Then it's fed to the reactor. In the reactor, you increase the temperature to 400, 500, or 600 degrees Celsius. And then you have basically the knockout section. There we are able to collect the liquids. The gas is basically entrained, is sent to the flare, but it's also measured, quantified, and also the composition is determined. And in the end, we will disconnect all the elements and we will be able to collect the char, which will remain in the reactor.
In SYSCHEMIQ Work Package 3, we sort and pre-treat plastic waste as feedstock for two complementary recycling routes, mechanical recycling and chemical recycling via pyrolysis. In pyrolysis, it is still challenging to fully understand how plastics composition, but especially how contaminants present in plastic waste affect the quality of pyrolysis oil. That's why we have joined forces with Ghent University, Maastricht University, and SABIC to build this pyrolysis experimental unit. Experimental data coming from this unit will be used to build a recycling quality model, what we call the RQ-Chem model, which quantifies the quality of plastic waste streams going to chemical recycling, telling us which streams are more suitable or less suitable for pyrolysis.
And with this unit, we can really track how much liquid is formed, how much gas is formed, how much solids, but also the impurities. And that's really the key element of this unit. We're able to track the impurities, chlorine, bromine, but also the metals.
This unit was inspired by modern thermopyrolysis systems both at bench and industrial scale. We try to design this unit to be continuous, flexible, and well controlled. We did it in a way that we can do the pre-treatment while cleaning the plastics, but also really easily change the key parameters in the reactors.
This unit is fundamental for the SYSCHEMIQ project to understand the cause-effect relationship between plastic waste and pyrolysis oil quality. This is important to make the best choice on sorting and pretreatment steps needed to pretreat plastic waste, but this also helps us to secure the quality of pyrolysis oil, which makes integration easier with existing petrochemical assets. This is a great example on how academia and industry collaborate with European funding to bridge the knowledge gap in plastic circularity.
So we are working in this way, and also replication strategies are really important. For example, to share the first results of the project and the approach of SYSCHEMIQ, we organized workshop and webinars across the European countries involved. But also we are trying to involve citizens through city labs to co-create recycling behaviors. So the success of this kind of initiatives or project depends from the collaboration of all these actors, so industries, research, institutions, and citizens. So a tangible collaboration can help to address one of the most pressing challenges, environmental challenges in Europe. So thank you, and if you are interested in getting in touch with some of us and of SYSCHEMIQ partners, you can send us an email, or if you want to know about the next steps and the next results of the project, you can follow us on social media.